Welcome everybody to the webinar. Sorry, I was still muted today. Today we're going to be talking about adapting to a new space war, sponsored by our friends over at INTEGRASYS. My name is Brad Grady. I'm president and COO of NSR, an analysis Mason company. I focus on government and military mobility, kind of all sorts of things in the comms layer. We have some really great panelists here today. But we're going to talk kind of about a bunch of different topics focused in on kind of the interplay of cyber jamming, cybersecurity, RF defense techniques, how we build kind of these current new next generation connectivity services out in the battlefield in kind of these new kind of operational environments that we're facing. So with me today, I have Alvaro Sanchez from INTEGRASYS, Tim Winter from STI Direct, Carlos Labrador, apologize, Carlos, if I said your last name wrong, from ACOG Solutions, and Tim Schroer from CPI. So the run of the show today is we'll do a quick little introduction of just kind of scene setting and kind of show some slides about how we at NSR think the market is. Alvaro will share a little bit of content, and then we will get all into Q&A. So for those following along at home, there is an ability to ask your questions. I don't know if it's up or down, so go to the right spot on your interface and type in your questions, and we will be sure to get them answered either live here or there'll be follow-up afterwards. So with that, let's get into it. Let me share this. So adapting to the new space war. Just, my quick sales pitch, NSR, Analysis Makes a company. If you're not familiar with it, we're kind of market research consulting folks focused in on satellite and space, doing all kinds of things around the world. I can focus on the government and military sector. But let's really get into the data. So between 2020 and 2030, we see the market in kind of three pillars. About $1.2 trillion in cumulative revenues, 24,850 satellites to be launched, and 504,000 petabytes of data being transmitted kind of through space. Now, some of that's from Earth observation satellites where it's mostly generated in space, but the vast majority of that, we'll get into what that data looks like, comes from satellite communications. And between 2020 and 2030, you can kind of see this volume of data growth. And this is not unique to kind of government space or commercial space. Just the vast volumes of information is significantly increasing. A lot of this is from non-geo, so during the Q&A sessions, we'll talk kind of about some of these multi-orbit and kind of how government militaries are thinking about kind of integrating or deploying these systems alongside their more legacy platforms. 51% is non-geo HTS SATCOM growth, 27% CAGR between 2020 and 2030 for kind of data at top line revenues or top line figures. But we look at this and we kind of say, okay, that's great that these things are happening, but let's focus in on security. Now, there's obviously a couple of really big headlines that I'm sure that we'll get questions and we will kind of talk about. But jamming and kind of RF security is not a new concept in the satellite sector. Arabsat, a headline from 2014, all of us can kind of find stories from, days gone past of either unintentional or intentional jamming for broadcast services or connectivity of this transponder wasn't working. Now we had to switch to this. And we kind of had to respond to these kind of instances on the fly. The one, I think, big difference now is we're starting to see the sophistication of jamming and sophistication of kind of these security incidents move beyond just pure RF into the cybersecurity layer, into maybe even the physical layer, such that kind of in the whole Russia-Ukraine invasion, there's obviously the Viasat hack, there's obviously Starlink kind of news that's coming out of there. There's all the alerts to focus on securing and adopting security best practices in this, satellite communication sector. So there's lots of kind of factors that are coming in and, topics that we're talking about today. And just within this electronic warfare domain, EW, you kind of look and see this notational picture that I picked up from the Joint Air Power JPAC. And you can kind of try to find where satellite fits in this very complex electromagnetic spectrum, where U.S. Space Force and other kind of NATO, other government military operators have really started to have solid understandings that the electromagnetic spectrum is a warfighting domain that must be protected, that must be defended, that maybe you have to operate in a contested, denied environment. And this increasingly has to happen across more and more systems in order to deliver the data and service and applications that need to happen at the edge of the network. And so how is this being implemented? So from our data that we did, we published an annual report called our Government Military Satellite Communications Study. It's 18th edition, the 19th edition. It's coming out this year. But by 2030, we see 821,000 terminals being deployed, for commercial terminals being deployed in the government military sector. Now, a lot of those are going to be kind of the MSS, L-band style terminals, or handhelds, sat phones, and those kinds of things. So not entirely in the same world as VSAT jamming, but they still operate in the electronic domain. They still provide critical services. They still do other kinds of, very critical mission services. And they have to operate in this kind of network of networks and services and applications. Now we flip that around and we focus on just the VSAT world, which we're going to spend most of our time talking about in today. We see over 20% CAGR for just the HTS services. So a migration from wide beam, FSS spot, FSS architectures down to spot beams and GEO and non-GEO. There's a little tiny slice of the pie that you can kind of see up at the top of the chart for 2030 for non-GEO. But it's this migration that we see progressing over the next 10 years here. And all of this is being driven by this increased throughput requirements. About 51 gigabits per second, according to our data in 2020, going all the way up to a terabit a second or 1,000 gigabits per second by 2030. More than 50% of this in 2020 was delivered by wide beam, again, kind of mirroring where we see in service units. But by 2030, only 6% is going to be from FSS, as we see a huge amount of increased bandwidth demand coming from the HTS architectures in GEO and non-GEO, which will account for about 70% of throughput requirements. And it's this real changing architectures that have military and government planners kind of trying to understand what are some of the unique characterizations of resiliency and redundancy and kind of all the R's that come out of Space Force and other government and military operators around the world against some of these physical RF cybersecurity and kind of operating in a contested, denied environment in this very complex electromagnetic spectrum with sophisticated, near state, pure state operators, and all those other kinds of things that we're seeing today. So what's driving all of this demand, and what, kind of how are we going to talk about and do all that kind of stuff? ISR, intelligence, surveillance, reconnaissance demands are on the rise. More sensors, more platforms, more sophisticated requirements for data intelligence. We've seen that already in kind of the utilization of Earth observation data and kind of tactical intelligence kind of, on the battlefield, and being able to move that from point A to point B has very, sophisticated and kind of real world advantages. Operations are requiring real-time, robust collaboration. Teams and Zoom calls are not just really a domain of businesses in the conference room. They're being pushed all the way out to the tactical edge of the network, which again changes the requirements of network complexity. And overall deployments are just getting more complex. It's not just large scale operations. It's 1,000 little tiny one-off operations doing very tactical things, moving across kind of the entire domain and battlefield. But overall, more data to more places is requiring robust connectivity solutions, and robust connectivity solutions mean that we have to start talking about kind of how do we operate in these environments, and that's what kind of the panel here today is to discuss. So with that, I'll turn it over to Alvaro, who has a slide and a couple of comments you'd like to take. Alvaro.
Thank you, Brad. Thanks for that excellent interaction. I wanted to mention about what we see in the new space and what in the new space war, or what we see that are the effects of a more dynamic, let's say, space battlefield. We are seeing a lot of jamming. So whether it's provoking or terrestrially or through satellite intelligence. So some of these capabilities we have internally, but also providing intelligence for enemy signals, geolocating them, monitoring all the spectrum in order to prevent as well as inhibit signals to coexist. Also, let's say that the jamming is a new way of RF security with if you combine it with anti-jamming capabilities. So only you can receive what it has been jammed. Also, sense and intercept. For a long time, we have seen how UAVs have been able to avoid, but also to intercept, as well as looking at spoofing and telemetry attacks. We see that as a major potential threat in the coming conflicts. Also, how to mitigate those. So we see that anti-jamming capabilities are very demanded. Also, cybersecurity protection, especially of firmware hacking, where you are able to reload a given firmware. That's something we are doing for multiple companies. Record and decode, as well as translate in foreign languages where the conflict is. Sense and avoid potential threats where a flying object is being threatened. Optimize modcuts, margin QoSs, managed by monitoring the capabilities to have a better resilient network, as well as more available, faster deployment for deployables, tacticals, as well as mission assurance with capabilities that make sure that the mission is accomplished. So with those thoughts, I want to take the opportunity to leave the word to Brad and introduce our panel. Thank you very much.
Thanks, Alvaro. So we have a great panel here to talk about kind of all these things. There's already a couple of questions coming in, so be sure to use the Q&A feature to be involved as well. So Tim Troyer, let's start with you. What part do you see of the SATCOM technology stack as having the most vulnerabilities? And those, I think, could be anything from the satellites themselves to the RF layer, the ground terminal, network management functions. How do you folks think about security?
Sure. I think that each one of those has the, its own level of sensitivity and what goes on. There's been a lot of effort in the past to protect TT&C links to satellites so that they can't be commanded to do the wrong thing, and there's very good protection in general for that. You can handle that at the RF point by making sure that your receiver is looking for your signal and not something else, and have the right encryption on it. So I think that part's okay. Obviously, the RF link itself for the traffic is always something that can be interfered with another signal, and that can be enough to overcome the signal you're trying to transmit, or it can be something that's a protected waveform or something that you have in between. Some of the very earliest jamming that we saw, obviously, was in the early days of HBO, Captain Midnight. I was involved with that years ago, where somebody intentionally jammed a video signal. So that's a little different than a military objective, but in the end, it did the same thing. It disrupted the communications and was a potential problem. What happened in that case was the operator themselves were not able to uplink a higher power level and capture the transponder, which was changed operationally after that event. So that's something where military systems can take advantage of that, use waveforms and power levels to balance out and overcome that problem. But it is still a problem. And then, as we've seen in some of the things in the news recently, some of these attacks were not through the RF at all, but on the ground with the data network and cybersecurity and what's happening there. So clearly, that's been a concern for a long time. Companies have been very careful to protect against that, but obviously no protection has been 100% secure on that. So there's still vulnerabilities there. So I guess what I see with that is each one is still something of concern. And while the RF link itself is the thing that's most obvious to all of us, after all, you're transmitting to a satellite, even in LEO, MEO, or GEO, someone else can overcome that same signal. That's not the only thing that's a concern and has to be monitored, even though it's the thing that probably we think about first.
Yeah, Tim Winter, I want to kind of bring you in here on kind of the ground view of things from kind of that perspective. How do you see things developing? And kind of Tim mentioned a little bit about, you know, waveforms and those sorts of things. So how does this all fit in your kind of viewpoints?
Yeah, absolutely. And Brad Navarro, thank you very much for hosting this panel. I think it's incredibly important and timely, especially with what we're seeing in the conflict in Ukraine and how that has highlighted sort of the changing world of satellite communications, especially on the battlefield. As Tim mentioned, you know, I think the complexities of our satellite networks continue to increase. And what I mean by that, he mentioned that there are now vulnerabilities, certainly on the ground component side, the terrestrial network component of a satellite communications network. You couple that with cloud integration and further what I call sort of ownership fragmentation. You know, it's not really having end-to-end satellite communication network may not be, you know, the staple going forward. There might be cloud component to it, there's terrestrial component, and then obviously there's the RF energy component to it. But as we see in the conflict in Ukraine, you know, the proof points that have been presented in that conflict show the need for, you know, interoperability. Obviously, Elon always gets his press, and Starlink was able to respond quickly. But look, you're not always going to be able to back up your truck across the border and drop off a bunch of proprietary terminals. I think what this has highlighted, so albeit there's a success there with another constellation and ready capacity in a LEO form, you know, there's some things that are highlighted for our industry that aren't quite a success. You know, closed architecture is really something that is a problem and has been a problem for decades. So now you guys start talking about open architecture and standards. Brad, you mentioned the utilization of multi-orbit. How do we utilize commercial assets and military space assets jointly and together to provide that redundancy and resiliency? So, you know, the battlefield is getting more complex. Our segment of the communication world is getting more complex. But I think, like I said, we're seeing in real time sort of some of the challenges and opportunities. You know, so we look at, when you talk about the ground segment, we look at that open architecture and embracing standardization, and that's coming. And then you couple in 5G and the standards that are being developed there. That will certainly be part of the solution set. But you got to enable multi-orbit. You know, the user wants to deploy a terminal outside the wire in a battlefield and know that they can utilize multiple constellations in multiple orbits at any time that they deem necessary. So these are all factors that in our tenets of our roadmap as we develop, I'll say, the next generation of ground segment components.
So Carlos, if I understand your position here, you're the one stitching all of this stuff together. So can you maybe explain a little bit about how you're approaching this and maybe where responsibility falls for kind of providing a lot of these kind of services to government and military customers?
Well, thank you, Brad. Sure. From our experience and the way we see it, we do collaborate in let's say, both sides, the civil side and also the governmental side. And from our point of view, what we understand is that at some point, the DoDs and also some of the governmental services are something that it's strategical for a country from all the side of the communications and also the observation capabilities that the country can have. So it's very, very important that I believe that the countries in the side of the governments, they understand the state of the technology in the way they can implement in the different requirements when they are looking forward to have the best technology and to be safe. So we understand that communications, for example, it's just intelligence nowadays of a country. I think this is something clear. And intelligence, after all, is the thing to make, to ensure that they're taking the right decisions. So at some point, I think that it should be mandatory that the governments, when they do the requirements of the needs that they were going to have on their constellations, also in the ground segment side, they always take care of to be well protected. And well, obviously it's just the same in the civil side, but I think it's very, very important when there's a threat, as Alvaro said before, that we can understand where's the threat coming from and what is the threat actually. Sometimes in the civil side, what we find is that this is not more than a threat. It's let's say it's an unintended problem. Okay, so it's just a problem that you need to solve it, and you need to continue with your communication or just with the connection. Some other cases you need to know exactly where the threat is coming so that you can take the right decision. So yes, there's a difference. When I would say that the main difference will be if there's intention or not, and to understand where or not is the threat. Also in this case is when the countries and also the operators need to be well prepared. Yeah.
Great, thanks. Alvaro, I want to bring you in here. So we've talked a lot about jamming. That's kind of been always a thing, and maybe we've always had this kind of unintentional versus intentional, and we've been maybe a little nicer in terms of those kinds of things. But does the intent behind the attack change some of the tools and resources that you're bringing into the market here?
Yes, absolutely. So it is what we're saying in the latest conflicts is a different way of attacking that we used to see in the 2014 with all the, let's say, legacy broadcast contents, more politically than any conflict related. And we are seeing a much more intelligence attacks and more difficult too. When you look at that physically can be canceled and things that physically might be more challenging. So it may when the let's say that the enemy is stronger in this regard, it makes you to find new ways, new solutions, and innovate a lot. So in that regard, yes, I think that technology is moving with new threats. We are continuing to innovate and to make new assessments. Last month, we won the most innovative technology award for the government use, and which we are very proud, and the team is excellent. And but we continue because the only way to be safer is by being prepared for what is coming, or what it is seeing as a future potential threat. So looking ahead.
Yeah, no, absolutely. Great, thank you. So we have a question from one of the audience, so please do kind of continue to bring in your questions. And this is, I'll kind of open it up to whoever wants to respond first. And the question is on the convergence of EWRF kind of attacks and cyber effects. How do we think about kind of the multiplication of these combined attacks, and what sort of mitigations can we bring to the table? So I don't know, Vera, if you want to start, and then maybe we'll go to Tim Winter.
So for cybersecurity, we have a set of products that are for, let's say, canceling threats on the hardware point of view. One of the most difficult attacks is when you damage completely the hardware in a cyber way that you cannot recall or reload or repair remotely. So for that, we use a little hardware, whether it's in a chipset or into an external box that loads a secure firmware and allows no contact with the exterior. So it's a secure box, a black box, where enables that automation of reloading anytime that it is not operational. So in that regard, recovers anything that happens. So everything is hackable, but reloads. So it's a hack automatically. So in that regard, it's an excellent solution for that. Also, one of the threats that we have seen in the last years, not years, is that in borders, cell phones from the soldiers are being hacked. And through the cell phones, there is a threat to act into different systems of mobile being platform or just a bagel, but it is a big threat. So we see what are the pirate cell towers that can affect. This is at the cyber side. In the electronic warfare, we do a lot, whether it's attacking, whether it's defending, whether it's knowing very well what it can be defended and what not, and what how you attack more efficiently. We have been doing also monitoring for intelligence, ISR applications where you need to pinpoint a source or where you need to know how much traffic there is in a given location for knowing what is the best time to provide a threat. So there are a lot of capabilities or automated things for not being threatened. So in that regard, yeah, there is a lot of to do.
Yeah, it's Tim Winter. I want to kind of bring you in here and let's talk about maybe encryption, right? I mean, I think that's one of the big, like, kind of, you talk about whatever, and then encryption kind of follows along all of this conversation. So how do you see these kinds of RF cyber and all that kind of stuff happening?
Yeah, absolutely. And like I said, it's just these networks are getting a little more and more complex. The adversaries are getting smarter every day, and they're very dynamic in their vectors of attack, the way that they attack, and how they implement their trade. And so whether we talk about zero trust architecture more on the cyber side or some of the RF security measures that we put in place, they're all important. We try to embrace a sort of a multi-layered security approach that you talk about resiliency, but it can't be static. It has to be dynamic. It has to be, as Alvaro mentioned, you have to continually work the problem, continue to stay ahead of the adversary. And we have a sort of a construct that we operate in, where we detect, mitigate, prevent, and predict. The first step, sort of detect. You can't really sort of mitigate a risk you can't detect. So it's very important to understand if it's AJ, if it's anti-jam or an anti-interference capability, understand where the interference is coming from, understand how that is taking place. And then you can implement some mitigation, techniques. We have a platform, Scissor, that does sort of some that handles our anti-jam, anti-interference issues. I'll say, but there's also LPI, LPD. There's a physical component to low probability of detection. I think even to reference Ukraine as well, they could see Starlink terminals are hard to find. They look like a SATCOM terminal. And that's, makes it they're an element of ease of detection. So it's even a physical LPD that sometimes people don't think about. But then we talk about prevent, sort of our third stage of sort of our construct. And you talked about encryption, and that's our Transect capability, which exists on our Evolution Defense platform, which has been very effective for TDMA networks. And then, FIP certification, that's really more of a US certification. But once again, I go to standardization certifications. And these elements are very important. And they're important when you design your next gen platform. In other words, they're harder to insert once a platform is developed and deployed, but they really have to be thought about when a next gen platform is designed. So as Alvaro said, it's a continual work in progress to stay ahead of the adversaries, but you got to have sort of a construct and a template to work from to deploy your tools.
Yeah, so you mentioned a couple of keywords in my mind was zero trust, encryption, kind of this paradigm of response. Um, so how does kind of put that all on one side, but how are you thinking about supply chain issues and kind of ensuring supply chain security and facing all those kind of national, different paradigms and those sorts of things?
Yeah, it's a great question, and like I said, we've lived through some supply chain risk has been highlighted by a couple of things that have happened over the last couple of years, right? Obviously, the COVID ripple, and we could talk about supply chain challenges on the chip side, but that is also highlighted. But the conflict in Ukraine has also highlighted some geopolitical risk elements. Whether you want to talk about launch, we've seen that play out in our industry and have a tremendous effect. But there are obvious geopolitical risks and concerns with supply chain. Look, are we going to see a pullback from globalization? As some are talking about, I don't think so. Who knows? We'll see how that plays out. But for someone to say that geopolitical risk is not a real and tangible threat to supply chain isn't really paying attention. So it's real. It's there. It's a significant challenge. But it speaks to vendor diversification, right? You have to have that multiple sources of content. At ST Engineering, we are a manufacturer as well. So we manufacture, a majority of our hardware products and services. That helps mitigate the risk a little bit, but the supply chain risk is not going away. And look, we've seen, whether it's chip shortage, okay, and yeah, other foundries are coming online, but it's going to take a significant amount of time for them to do so, or whether it's geopolitical risk, they have to be managed. And I think what we've seen, whether it be COVID, a pandemic, or the conflict in Ukraine, they've both highlighted the need to actively manage supply chain. And there's no easy answers out there. It just has to be actively managed.
So Tim, sure, I'm kind of curious to get your views, being the other side of the ground segment here. How do you see supply chains and security and all that kind of stuff?
Sure. Well, we've seen the same kind of problems with semiconductors. That's probably been the biggest impact on us with supply chain. We obviously build big antennas using a lot of steel and aluminum. The conflict around the world and the administration before it already had a big impact on the steel and aluminum supply chain, which caused prices to increase. And that's just part of our normal everyday doing business, building big structures and large antennas, that sort of thing. So we've seen that just as the ongoing cost of doing business and had to deal with it. We've redesigned our products wherever possible to maximize the content that we build ourselves. Big antennas, we take in raw steel and aluminum and put out antennas themselves. So we've optimized both the materials we use there as well as to minimize the fabrication and installation time to try to make that faster and easier to do as much protection of that as we can. So that's the piece of it there. One of the comments that I wanted to make about the other issue with looking at the security and EW, RF security, the rest of it, one of the things I think has become more obvious is we need to be vigilant about monitoring what's going on with the signals, with the infrastructure, with the ground infrastructure as well, to protect against intrusions and to know what's going on in the normal situation. For a long time, many satellite links were just run on autopilot, basically, with nobody paying attention. Once you got it up and going, then you just presumed it would always work. Well, if that's the way you treat it without monitoring its normal operation, both from a digital standpoint as well as the RF, then you really don't know the threshold of when you are seeing a problem. And is it just some failure or some incident that happened with the equipment, or is something really going on that's an adversarial activity? So I think that's an important part of what needs to be done to protect SATCOM and the whole infrastructure.
Mm-hmm. Yeah, no, Barrett, I think this probably gets to some of your statements of this characterization, monitoring, and then automation and those sorts of things that you guys are bringing to the table at INTEGRASYS, right?
Yes, indeed. We bring excellent monitoring systems that detect and mitigate threats whether it's from a faulty hardware, whether it's from something else that leaks, and even monitor remotely and act over the hubs. So any MOD is able to look at what it is happening in all their remotes in the network, if the buck is faulty or if the LNB, geolocate them and know exactly what they need to change in case they need to fly a helicopter into the location, or also in many occasions can fix remotely just by reconfiguring automatically. So it is monitoring is critically important, but then APIs to completely automate all the functions that you must do, all the processes that you must do. So bringing those capabilities with the antennas, with the modems, with the integrators, it's a very, very important. I remember last Space Symposium panel discussion I had, one of the gentlemen from US Spacecom was saying, I need an integrated solution that somebody like ICAX can provide, thanks to working together between the antenna, the modems, and the softwares. So this is something crucial for being able to succeed on any mission.
Yeah, and Carlos, I'm curious to get your thoughts here of the importance of having these kind of supply chain views of, close relationships with other vendors, of bringing a kind of, fully nailed down cybersecure, RF secure, et cetera, solution to the market. How do you see that?
I think, Brad, I fully agree with Alvaro in this case. I think that we all agree also with both teams. In terms of the responsibility, it's sometimes it's very hard, because the things change so fast, and there's, let's say, the bad guys. Sometimes even they're creative, and they never stop moving. So I think it's even let's start saying that the responsibility starts on us, and let's say on the good guys, that we try to do the right stuff that could stop those threats, those attacks, and how smart or how capable we are to stop them. No, so when we get to the point that we go to the final customers, or the ones that are going to launch the satellites, they're going to get this huge risk to get the cameras, the electronic, the radars, maybe the payloads, the communication payloads, and then now. Before this was something that was not happening, but now it is. And then these people, that they're getting the huge risk to spend huge amounts of money, and they can just blow up in 1 second if somebody wants to, or just with the malware, with the laser, or with whatever. Let's say it's becoming something complex, as Tim was saying before. So where do the responsibilities start? It starts on us to give them the right things and the right knowledge and the right state of art, what we can do. It's very important what Alvaro said from our point of view. There's plenty of players here, and all of us, we have a sort of responsibility starting on the prevent systems. For sure, companies like my company in this case, that we are integrators and we see the total picture, maybe we are more responsible than any other else. So from my point of view, this will be the first point. The second point is those customers that are not taking the caution and are not preventing and are not investing on this, they are, I don't know how I could say it, no, but they, for sure, the responsibles of any kind of problem that we have in the future. And as I said before, once you get to the point of the customer, it's very important to have the right tools to understand the threat, the problem, the attack, and to detect the problem, and then to have the right tools to stop it on time, because sometimes it's too late. So yeah, I think that responsibility is never just from somebody. I think that we all need to be prepared. We need to invest, and we need to know that this is something very complex. It's changing day by day, and we need to be very, 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 very active. Yeah.
Yeah, absolutely. I think it's that collaborative kind of approach to find that solution.
Yeah, we need to be together completely. Yeah, that will be the point.
Yeah, absolutely. I want to dig a little deeper into the mitigation and resolution aspect of things. How do you see the ability and kind of that automation influencing your ability to kind of, find, mitigate, and then respond to the solution, because it's great to be able to report about it, but ultimately people still want to have, their connection solutions. So how do you see that chain evolving?
This question is for me also?
Yeah, Carlos. Yeah, sorry.
I don't know if you can do it again, sorry.
Yeah, so I was curious to dig in deeper onto the response side, right? So let's say you've identified that there is, some incident, there's a problem. What do you do next?
Yeah, well, I think that just in this webinar, there's I think there's the right people that we could have, all of us, we could have the right answer for that. And I think that the right answer would be the mitigation tools that we might have. I think that from the side of CPI, they also work with constantly. They're looking for this. We're in touch constantly. Also from the side of iDirect, and what I really I'm impressed. It's in this webinar with one of the solutions that INTEGRASYS is putting on the table with all the solutions of the CleanRF and I think that this will be one of the let's say the right answer in this case will be to be prepared and have the right tool to mitigate and to find the right partner in the vertical that it touches, to find the right, let's say, technological partner to be prepared. In this case, for example, INTEGRASYS.
Yeah.
Thank
Absolutely.
you, Carlos. If I may add into there, so basically we see that as more automation into the user processes, the better. More streamlined operations. So if, okay, there is an interference, okay, we geolocate that, okay, what happens? So as more automation into those processes take place, more rapid response, more resilient network because a rapid response happens. Also, for example, our anti-jamming capability, what we implemented is a scan of multiple carriers and automatically cancels real time. So more automation into that, there is none. So in that regard, as more chain you can automate on the monitoring side, on the multi-orbit. So looking at many paths and looking at what paths will be more target to the requirements in a particular moment, in a particular position. So looking at all that and being completely automatically changing paths depending on what is the most available or the preferred path to communicate, that's a big strength in the multi-orbit environment or even in geo. Looking at multiple antennas, multiple places, how can we enable communications 100% of the time? And nobody needed to require to click a button to change. So in that regard, it's all that automation makes much more resilient the network and much more available. And that's, I think, that where we need to go.
Yeah, so I see a lot of head shaking, Tim Winter. How do you see this? And I think, I think Alvaro hit on a couple of really, really big points. And I like to call it the softwarization of space, right? It's this moving things that, like Tim said, were very static and in kind of, you build once, you just let it sit there and maybe you don't even pay attention again until the satellite falls out of the sky or whatever. How do you see your role here as, a modem manufacturer interacting with kind of being open architecture, but still being highly orchestrated with kind of space and service provision and all that kind of stuff?
Yeah, it's a great question. Like I said, it's a very dynamic time in our industry as many businesses, including ours, migrate to more of a software focused business. With the level of onboard processing that's coming and software-defined satellites and the flexibility that type of space asset can bring, it has to be leveraged by the ground segment. It can't be limited by the ground segment. And to Alvaro's point, when you start talking to machine learning or building learning elements into, that type of architecture, this stuff has to be automated, whether you're jumping from a geo constellation to a MEO or LEO, choosing best available network. There will be a man or woman in the loop, certainly to some extent, but the more that these networks can do that automatically, the better. And whether it's from interference learning, building out a library of what certain interference signals look like and being able to react to that, or like I said, jumping from a constellation, from a geo-based constellation to a LEO. Look, there's no hiding RF energy is tough, right? And so, and our adversaries know where all our geo satellites are. And, when the shooting starts, it gets really hard to hide RF energy. And so we have to build out, there has to be contingencies, and we will get to the point where they are automated, where networks and communication can be enabled, when the shooting starts. So, like I said, it's a great question. I think it's a pivot point in our industry as we really start to become software focused. Will the black boxes become commoditized? Probably. And so, as we look at software defined radios, as the 5G radios come online, et cetera, being able to pull down different images, whether it be waveforms, whether it be software enabled capabilities, pull that down from the cloud and enable those immediately on, satellite communication networks. So I think it's pretty exciting, but it's gonna be very dynamic, and to be honest, it's moving pretty fast.
Yes, it's very fast. I think it's, it's like the space industry is kind of getting it back into where the, terrestrial telecom is, right? Of every 18 months, there's something new changing, et cetera. It's a fun time to be here, but definitely. So if you still do have questions, you're sitting at home, you want to ask questions, please use the Q&A function to get them, and we will make sure that they get asked. So Tim Shorten, I want to shift over to you, because you're kind of on the other side of this equation on stuff that may or may not be able to be softwareized, right? I mean, we can go down the road of flat panels, but let's not, other than that, they exist. But I'm curious, big antennas are kind of big, juicy targets. How are you seeing the new kind of evolution of the ground segment evolving in this kind of, new space era?
Yeah, well, there's some requests out there that are beyond theoretical, shall we say, or beyond the physical, that we know that we won't be able to build an antenna that can cover every satellite on every orbit and paint it on the top of a vehicle and make it work everywhere. But nonetheless, there's ways to get diversity without having to go that far. One of the things about military comm, I was in the Defense Communications Agency years ago, which was really established because there was difficulty for the military to communicate over long distances between services. And the main thing that they did to provide sustainable communications was diverse routing. So at that point, the idea was for things that were really strategic, there wasn't just one link was the only way to get there to pass the data. And I think we're in that kind of world today with SATCOM. We tend to think of SATCOM systems as you set up one link on one satellite, that's it. But in reality, we don't need to do that. Already, high throughput satellites and very high throughput satellites, there's a lot of diversity going on with the gateways in those today that's really initially put in to overcome weather fades, but it's actually a physical diversity, physical security that's added by doing that as well. If one gateway completely failed, then you have another one that has a high probability of getting through in that same satellite. The user terminals that are like small VSATs pointed at a particular satellite, yeah, it's difficult for those to just move quickly from one satellite to the other, mostly because of just the cost of doing it. People put in VSATs with fixed antennas that always point at only one satellite, and to go change that to another satellite, you have to have a truck roll to go out and move the antenna. Well, that's true, but I think that can change. Military users don't operate that way today. They have motorized antennas. Most of them want auto acquisition, which can easily switch from one satellite to another and be able to use diversity that way to change the link if there's jamming or some interference or some physical problem with the satellite. So I think the solution that's going to really be most attractive for government users in this environment is a system that can intelligently switch between different satellites. DoD would like it to be even with different orbits. That's coming. We build some that can do that as well. But certainly to be able to switch between different satellites, have a in-band or out-of-band command basically to let that happen is one way to do that, and then use that diversity to provide protection for the link.
Yeah, no, and I think that starts to get into these new operation paradigms. And Tim Winter and Amelia, I think this might be a question not for you, but Tim, if you have thoughts there. Blockchain, right? So I think Tim Winter mentioned zero trust, and the one thing that I don't know if I caught it or you didn't mention it, was like blockchain and other types of stuff. So are there new tools in the toolkit today for solving some of these cyber and physical and RF problems?
Yeah, and I want to be careful not to speak out of school. That's certainly not my expertise. But look, the reality is, for SATCOM to grow, and the numbers, Brad, that you presented, and to tap new markets, which are sort of necessary for all these constellations to work. There's a lot of telco activity right there, right? And there's and that means SATCOM industry's got to adopt standards, but that also means we have to get smart on sort of the terrestrial side of cybersecurity. There is zero trust architecture. That's sort of a newer concept for us. Like I said, we've focused, a transec and encryption on the RF side of things, but that's not going to be good enough anymore. This is cybersecurity is a qualifying criteria. It's something that must be baked into any next gen platform and/or software that is put into play. Could blockchain play a role in that? Absolutely. Could some sort of quantum, what does that lead into? Certainly. But I think what's important, what's a takeaway, is the satellite industry can no longer look inside for that type of information, but has to be very, well educated on all of these cybersecurity, the new approaches to cybersecurity that are playing out on the terrestrial side, because we have to play exactly as telcos play if we want to be integrated into their networks. That's an absolute must. And like I said, a lot of these elements are what I've used qualifying criteria. They absolutely have to be there. It's a cost of doing business, and it'll become more and more important, especially in the government and military space. These networks have to work when under stress, and some of these sort of leading techniques will probably need to be implemented, because the offensive attacks are usually one step ahead of the defensive measures, especially on the cyber side. And so there needs to be a lot of, I think, industry collaboration with government to stay ahead of that problem. But could blockchain present itself? Absolutely. Could that be one of the solution? Other quantum, like I said, techniques, could they come to bear? Absolutely, I think so.
Cool, thanks. Carlos, I want to bring you in here too. And can we maybe compare and contrast your government business to your commercial business? Is there maybe some similarities, differences between those two groups that you see?
Sure, but I would like to add just something very fast, just what the team said. I fully agree with him. We should not invent the wheel again. I mean, and then all his point of view from what the telcos and all the knowledge that they have, I think it's something very useful. So that's a very significant point. We collaborate in both in the deployment of all over the 4-5G, and so this is true. And it's from my point of view, it's a very important point. And yes, and getting back to your to the question. Yeah, we do collaborate with both the kind of customers, with the governmentals and also with the private ones. And usually it is completely different depending on the uses of the final customer, the requirements that they usually and the equipment that they want. Since it's incredible, because now it's known that all these kind of threats are very common, but this was not normalized since so far away in time. We start seeing on the cyber segment, they started introducing this kind of tools, maybe at least in our country, like 1 or 2 years ago, or in the terms of the cybersecurity I'm talking about, not in interference and this kind of problems. On the other side, on the military side, they've been requesting tools to protect themselves since like 10 years ago. That it's my expertise, since I've been working in SATCOM in the military side and collaborating at least with the Spanish government. So, yeah, it's true. It's way different. Compare one tender with another. When you see all the specifications and protections items that they include compared with the civil side. And I think, this is only my point of view, that today, even the civil satellites, they do not depend on the payload they have, observatory payloads, optronic or communications, even the civil ones are strategical assets of a country. So they all should be protected.
I think this gets into the let's all collaborate and be this holistic analysis and think of things as one system.
Yeah, completely. Yeah. Should be a network, all together, an ecosystem. Yeah,
absolutely. So final questions here. And Tim Schroeder, I'll start with you. Is there a skills gap in terms of cybersecurity? And this is an audience question that I really did like. So equipment makers are kind of moving to these managed service models. Is cybersecurity going to be one where maybe you have more education that you need to do with customers, or maybe there's a managed services opportunity? How do you see this skills gap versus business opportunity evolving?
Yeah, it's an interesting question. I mean, we mostly make hardware, so the hardware doesn't have a problem like that. But of course, all that hardware is driven by software. So there's a processor in there somewhere that has to be dealing with that. And it is a significant issue. We as a company are fairly fortunate in that for a while we were part of General Dynamics. And General Dynamics is a big manufacturer of encryption equipment for the US government and was very concerned about cybersecurity. So we kind of got an extra dose of cybersecurity, being such a government contractor building the devices that were intended to protect government networks like that. Since we've been a part of CPI, obviously we've brought that same discipline to what we're doing in both our government business and our commercial business. So I'd say we're a little farther along than some of the others simply because of our history. Now, the legacy CPI had some problems with ransomware in the past. So they too, we as a corporation learned the hard way about being more vigilant about that. And we've completely revamped our internal IT infrastructure, which comes out to the products that we deliver as well. So I guess what I'm saying is that we've both had an education in how it should be and an education in hard knocks of how it should not be, and tried to learn from that. So in our own case, I hope that we've learned the lesson and that there isn't a gap for us. But it was not it was not something that happened without effort. There was a conscious desire to do that, and we spent money and time and effort on it, which let us close that gap. But it may not be the same with all the other manufacturers.
Great. Winter, how about you? How do you see this kind of evolving paradigm, and how do you see kind of INTEGRASYS fitting into this mix to help solve some of these problems here?
Yeah, and just real quickly, I don't think there's a skills, just to fall into that, to Tim's answer, whether it's skills gap. Obviously we have a long history working in the US government and over 30 MODs throughout the world. So we do take an aggressive approach towards cybersecurity, but like I said, things are happening fast. Change is happening fast, and there certainly is a challenge. And that skill set that you asked about is in high demand. There's no doubt about it. It's in high demand. It'll continue to be in high demand. And so getting those folks on board is, I think, will always be a challenge. But yeah, so, looking at, obviously we partner with INTEGRASYS quite a bit on many of their products and with some of our strategic customers, whether it be the satellite owner operators in Intelsat, Inmarsat, SES, or global service providers, Marlink, Speedcast, and the like. Their tools, I'll say products and services, bolt on well with our ground architecture right now, whether it be SatMotion. We talked about assisting with it with terminal acquisition. That's a great tool that has been appreciated by some of our partners. Or AluSat, constantly, getting operational efficiency out of your deployed megahertz will continue to always be important. Mentioned Clean RF, I'll say anti-interference tool. Also find a lot of demand. So it's been great working with INTEGRASYS. It's increased our value add to our partners, and we look forward to continuing to do so in the future.
Thanks. Carlos, how about you? How do you see this kind of conversation going forward?
Can you hear me? Yeah, okay. Well, from our point of view, I believe that there's one clear product from INTEGRASYS, that is what I said before, the Clean RF, about the one that can cancel the interference. And this is one of the best products that in this case can solve these problems. No, this is one of the things. Well, hold on one second. I will, sorry, Brad, I will need to just 10 seconds, okay? Excuse me.
Brad, as you mentioned before, blockchain, actually we are using some, in one of the projects we are doing that is called blockchain, we are using blockchain for cyber. So in that regard, yes, and it is something is being used, but from being very, very, very popular to being less popular lately. And another comment I wanted to make is that Team Sawyer, as larger the antenna is, the better gain you have, the better margin you have, and the more resilient. So I fully agree with Team comments on one is nothing, as it is said in the government world many times. So you need redundancy, you need different paths, you need different antennas, and you need multiple paths to communicate a high resilient link.
I am sorry, guys. I just were close to fall down. It's very, very, very hot here where we're doing the webinar, and I were close to lose my mind. So really sorry for that. I'm back up here. I drink some water, and I'm back here. Can you answer back, Brad? So sorry for that.
Yeah, no, I was just wondering kind of how you see this conversation evolving going forward, kind of cybersecurity and going those kinds of things.
So really sorry. It's like 500 million degrees over here. The summer is starting. Well, I think that now we all have something to talk about this webinar, no more than just the cybersecurity and all the threats. Well, first of all, I think this is very interesting, and I was going to end my point like saying that obviously all the countries that are strong in all the space force, and here we always take as a reference the United States and all the industry and capabilities that you have, and I think it's always good to learn about you. And I the first thing of all, I hope that this has been helpful for all the people that has been listening. It's always good for us to have companies like CPI and like iDirect here. And it's very good to see that there's also companies from our country that they can do a very good job. I would like to end up also saying that this is what I was trying to say before, but there was no blood in my brain, I think. And and it's that from our point of view, as I said, this is very complex. It's constantly changing. So we could have this conversation in 2 months, and it will maybe has changed with all the things that are happening. And from our point of view, I think, as we say, this ecosystem is very important. The change is very important. Companies like us are very important because we see the different verticals. And we would like to get in with all the knowledge. And for example, in this case, which was the example I was going to put, we are developing with INTEGRASYS and hopefully with many other companies, some tools so the operators and the final customers can feel safe. And well, that's actually the point of view. And thank you very much.
Yeah, thank you. Vero, last words.
So I appreciate very much everybody that has listened to the webinar. Thank you, Brad, for moderating. Thank you, team and Carlos for joining. For us, it's a great pleasure to grow with you. We have been growing significantly in all continents and growing the number of products, the number of technologies, the number of softwares and tools, thanks to partners like yourselves. And we will continue to grow with the work we will do in the future. So look forward to that and look forward supporting new users to new applications to solve new challenges. So with that, my final words.
Yeah, thanks everybody for tuning in. And if you need to get in touch, please feel free to reach out. I think all of us would be more than happy to continue the conversation. So Viro, thanks for having us and thanks for hosting us. And thanks Tim, and Carlos for participating today.
Thank you very much, Brad.
Thank you,
everybody.
Yeah, have a good day, everybody.
Thank you.
Thank you.